students, application of integration you are going to see. How integral is applied in mathematics. In mathematics, integral calculus is much applicable in various dimensions, various topics, but how in fundamental concept itself integral is applied, that we are going to look into that. We are going to see in exercise 11.4 problem number 4 how the integral is applied. A ball is thrown vertically upward from the ground. See the diagram. See this diagram. A ball is thrown. That means a person is standing and is throwing a ball like this, and it strikes the ground here. It strikes the ground. See, I am here throwing a ball. It goes up. It's projecting. So it goes up, again coming downward. So when it goes, it reaches the maximum height and reaches to the ground. It strikes the ground. This is the question. See here, when anything when you throw here, it will be just we are throwing here and reaches the ground. It strikes the ground, and initial velocity, final velocity, all that we are going to see. But here now this problem. Let us start. A ball is thrown vertically upward from the ground with this initial velocity, means the speed. The person is having a speed with the help of, that is 39.2 meter per second. Meter per second, at once you see it is rate of change of displacement, that is nothing but velocity. That is what here the person is giving with a force of 39.2 meter per second. And if the only force consider is that attributed the acceleration due to gravity. See, we are going to apply Newton's law here. With the help of Newton's law only, this problem can be solved. Okay. So that means, let us take, let u be the initial velocity at certain time t. Okay, first let me consider like this. Let u be the initial velocity. See, by the Newton's law of force, by the Newton's law, actual formula here, S is equal to ut plus of at square or of gt square. Anything you can consider. Acceleration, either you can take it as g or you can take it as a, depending on your wish. Here the question is, we are not going to take into that. Now it is upward motion. When you take upward motion, what happened? Downward motion, what would be g? G would be positive when, whether it is upward or downward. My question is very simple. When we are just throwing a stone or anything, the g is positive or negative? Positive, right? G is positive, negative, negative or positive? Because depending on the g only, we consider positive or negative. When it is upward, negative, remember that. So when it coming downward, it is positive. Remember, that is very, very important, students. So we are going to consider here this problem, S is equal to ut minus of gt square, because upward motion considered to be negative. That is the reason why I have taken into consideration is this. Usual formulas of gt square, but upward motion and downward motion, when we go up, it is negative. So we have taken like that. So here remember that it is 39.2 meter per second, that is what u, given that u is 39.2 meter per second, it is given. So that means we have to calculate what is s. S is equal to 39.2 and g, always you know that 9.8, that is acceleration, meter per second square. that is always we used to take, that is a fixed point it is, that is g is 9.8, that is g is a fixed value, so actually that is g. So, you take this value here of, in the place of g 9.8 and t square. This is what we have taken here. Now, 39.2 minus this 4.8, 9 means 182, 9 2s are 18, t square, that is equal to s. Now, we have this equation. S is equal to 39.2 minus 4.9 t square is the equation, that is the S. So, a person throwing a stone throw a ball, so from the ground level, and the equation we have, because it is upward motion we consider as negative. So, that is the reason why I put negative over here. So, that is what the equation here. When the ball strikes the ground, it strikes the ground. When the ball strikes the ground, that means S is equal to 0. So, by then S is 0. So, you substitute over here what happened here, 39.2 t minus 4.9 t square. Remember that 39.2 t minus this. Remember that, take 2 t common, 39.2 minus 4.9 t equal to 0. Therefore, t is equal to 0, or t is equal to 39.2 divided by 4.9, multiply by 10, because in order to avoid this, 392 by 49. So, multiply by 10, 392 by 49. So, we can cancel it here, 1 4 4s are like this. So, here you can cancel it here 8 times here, 8 9s are 72, then 8 4s are 34, 37, 39. So, we got t is equal to what is that, 8 seconds. 8 seconds we got. So, t is equal to 8 seconds. Just cancelling this one time, this is 8 times, it is getting cancelled. Now, we found out when the ball strikes the ground at the value of S is equal to this. So, it travels, total duration is 8 seconds, t is equal to 8 seconds, the total duration. From the point till the end, it is 8 seconds. That means, obviously, you know, this point, it is naturally we can say it is 4, because very simple way, but logically we can take. But what the question, let us take here. When the ball strikes the ground, we found out like this. What things they asked here, the speed with which the ball will it strikes the ground. So, the question asked like that way, the speed with which the ball strikes the ground. So, first of all, the ball strikes the ground, the space is 0, we found out the time, the total duration from the place till this we found out. The second one, the speed with which the ball strikes the ground. So, that means the speed which it strikes the ground. Here, what do you mean by this? The speed with which we strikes the ground. Here we found out the time, the t. So, next part what we have to take v here. What is v here in this one? Here S is nothing but what? S is equal to 39.2 t minus 4.9 t square. That means we want to know what is the rate of change of displacement is in velocity, as I told you. So here ds by dt, here it's 1, here 4.9 into 2t, that means 39.2 minus 9.8t here. When it strikes the ground, what happened about this part here? So you have to substitute the value of t here as when it strikes the ground. That means when t is equal to 8 seconds, what would be the velocity? That is what we want to know. When t is equal to 8 seconds, what would be the velocity? We want to know. That means v is equal to 39.2 minus 9.8 into 8, remember that. 39.2 minus 9.8, how much it is? 39.2 minus 8 8s are 64, 6, 72, 78. Just simplify here, 4 2's like this, here 8 9 and then this. V is equal to 39.2, since velocity is considered to be what? Actually velocity, this indicates downward. This negative indicate velocity is downward. So it goes up, again it downward. So then here the v is negative. So that is what the v we got is minus value 39.2 meter per second. 39.2 meter per second, that is what velocity. The speed with which the ball strikes the ground, by then the time factor is 8 seconds. We calculated v is equal to 39.2 meter per second. So that is the second one we have finished. How high the ball will rise? The maximum, how much height? The maximum. Here v is 0. So that means, third question, the height of the ball, it reaches the maximum. There it is v is 0. So by then we can take what is the value of t here. So we can very well simplify it, we can find out v is equal to 0. What is the time? Here t is equal to 4 seconds, because the total duration is 8, obviously that part will be 4. But we can calculate by way of calculation also, we can very well find out. What is v here? See, v is this one. So you can put the value of 0 here, so we can find out v is 0, 39.2 minus 9.8 t equal to 0. So that 9.8 t is equal to 39.2. So t is equal to 39.2 divided by 9.8. Here 392 by 98. Here it is 1, it is 4 times. So 4 seconds. So that means this is 4 seconds. Remember that the maximum height it reaches, it's 4. So here also we found out v is equal to 0, time is 4 seconds, reaches maximum 4. It strikes the ground, t is nothing but 8 seconds. That also we found out. Now the question is how high the ball will strike. So that means we have to take the original formula of S. S is equal to 39.2 t minus 4.9 t square. Thereby you substitute this t value, so that what would be the highest distance it reaches. So we want to know S of t, 39.2 t minus 4.9 t square. So, you substitute the value of t is equal to 4 seconds over here. So, that means S of 4 equal to 39.2 into 4 minus 4.9 into 16. Just multiply 39.2 into 4. 4 2s are 8, 9 4s are 36. So, 3 4s are 12 plus 3 15. So, 156.8 negative. So, 4.9 into 16, 9 6 are 36, the 9 6 are 54. Here 24 plus 9 33 38 7 78.4. So, remember that just multiply 4.9 and 16, 4.9 one decimal. Okay, 156.8 minus 78.4. So, finally we have to subtract this value. 8 minus 4 is 4, borrow 1. So, 16 minus 8 is 8 and then 7 and then here 14, 7 78. So, thus S of 4 is 78.4 meters. Here that is the distance has travelled, 78.4 meters. The height of the ball, reaches this place is 78.4 meters. So, this is the final result for the problem. So, 3 answers. One is this much. The first one, when the ball strikes the ground, time is 8 seconds. And second one, the speed with which the strikes the ground, that means we are calculating what would be the velocity. So, the velocity is 39.2. Since it is downward, this negative indicates is downwards. So, that is what 39.2 meter per second. And the final one, when it reaches the maximum height, what would be the displacement, by what would be the S? So, that is 78.4 meters it has travelled.